All right, welcome back, math people. Second part of 2.3, inverse of functions. Now the first part, think about what we did. You were given two functions and you're just asked to decide whether they were inverses or not. And you did that whole thing with algebra and you composed the two functions. Which when you think about it, that's kind of why we did 2.2 first. Because you had to learn how to compose functions. And once you knew how to do that, then you could use that little technique to determine if functions were inverses. Now, the question 20 in that whole area, these are the second types of questions. It's a little bit more challenging. You're just given a random old function, and then you have to determine what the inverse of that function is. And this is the stuff that you did in Con. These ones are a little bit more challenging with the algebra, some of them. So let's just go through the steps real quick. If you want to take notes, maybe just write this down. Email it to yourself, or put it in your notebook. Or do enough of these problems and you'll just memorize it. So finding the inverse. Step one is you replace the f of x with y. And we'll do it together. Just going to go through this quick. Then you exchange the x and y out. You interchange them. It's kind of weird. We're just going to do it. Then you're going to solve for y. And I wrote algebra. That's where you have a lot of algebra. Because once you exchange the x and the y's, you may end up with a lot of y's throughout your equation. You're going to have to get all the y's on one side. It's kind of like doing those things that a lot of you guys were shaky on when you had the formulas and you're given like s equals l I pi r squared or something, and you had to solve for one of the variables that was all mixed up in the formula. So that's the hard part right there. Then when you're done with that, instead of writing y, you just replace it with f to the negative 1 power, which means inverse. It doesn't really mean f to the negative 1. It's the inverse function of x. And then the last step is also tricky. Find the domain of the inverse function. And the way you find it is you have to find the range of the original function, which sometimes can be a little bit challenging. And just remember that. So the domain of the inverse is the same as the range of the original, and vice versa. So the range of the inverse is the domain of the original. So let's go and do a problem, see if it makes more sense. So I'm given a function, f of x equals square root x minus 5. So step one, replace this with y. Y, oh, you guys like the y's like that. Y equals square root x minus 5. Step two, exchange x and y's. This is not so bad. I only have one x, I only have one y, so I'm just going to do one swap. Oops. All right. Now, step three, the algebra. Solve for y. So now I have to be a little bit more, okay, what am I going to do? Well, y is inside of a square root. That's got to go. How do you get rid of a square root? Square. Whatever you do to one side of the equation, you've got to do the other side. Square that side too. So far, so good. When I square root, it disappears. This stays x squared. Now I have to get rid of that minus 5. That's easy. I'm just going to add 5 to both sides. I'm going to write it over here. So when I add the 5, it'll come over here, and I'm going to exchange the order. Y equals x squared plus 5. So that's my new function. And then the fourth step is, instead of writing y, I'm going to write inverse. So just to kind of use your eye of wisdom, step back a moment from this problem. We started with the original function, which was square root of x minus 5. And the inverse function, that's what that means, the inverse of f is x squared plus 5. And don't look for patterns and say, oh, well, it's kind of like you just squared it and then you change the minus to a plus. Just go through the steps, and then you'll come to the final part. So far, so good. Now, the last part, what's the domain of this function? And remember, the domain are the inputs. Now, you may be tempted, if you just stopped here, you'd say, well, x can be anything. X can be a negative number, it can be a positive number. Whatever x is, I can stick it into this function, and I'm going to get an answer. But remember, we can't do that. We have to go back to the original function and find out what the range is. So it's a little bit more potentially restricted. So the original function, the range of this one I can kind of do in my head. If you think about it, whatever x is, I can't let x I can't let whatever's in the parentheses be negative, right? So if x was like, say, 4 minus 5 is negative 1, I can't do square root of negative 1. Can't be done. If x is 3, I can't. So there's an automatic restriction that's built into this function. Once you realize that, then you think about, so what can this function equal? Well, it could be equal to 0, because if x was 5, 5 minus 5 is 0, the square root of 0, I can do that. And then I can do the square root of any positive number. So the range of this function, I'm not talking about the domain. The domain is like restricting x has to be greater than or equal to 5. That's the domain. But the range of the f of x is going to be all positive numbers, because the square root of whatever you're going to get is positive, and 0. You can do 0 too. So the range is how would you write that? I would write f of x is greater than or equal to 0. That's kind of my range. So that becomes the domain of this. So I'm going to write the domain, I'm just going to write like that. D of f of negative 1x is greater than or equal to 0. That's not too bad to write it that way. Makes sense? So remember, the domain is, you have to go back to the original function to figure that out, and you have to figure out the range, the outputs of the original function. So that can be a little tricky. Work through these. If you get stuck, look at the work solutions online for some of these problems. And that's all you have to do for this for today and for the weekend for the homework. So good luck. Namaste.